A hyperscale data center construction site is loud, chaotic, and moves thousands of tons of earth a day. But the directors responsible for delivering this facility don't manage the dirt. They manage the data. In week 2, the field teams report high momentum. They claim to have mobilized 129 personnel and logged over 10,000 man-hours. Looking at the outcomes matrix, the site is operating safely, with 0 incidents reported across those 10,260 hours. However, despite the safe hours and heavy manpower, the executive dashboard shows the overall project valuation is sitting at amber. It is actively failing its baseline targets. Project directors must strip away subjective field reports to expose the raw data. This split screen compares what the field claims is happening against the strict objective evidence actually submitted to the system. Physical work is completely irrelevant to the project baseline unless its data date, owner, and evidence are formally verified in the system. That is the record rule. The highest immediate risk to this project isn't a lack of physical labor. It is a failing engineering flow. This graphic maps the information bottleneck. 28 submissions entered the funnel, yielding 0 approved output. To track this, response aging measures elapsed days against the SLA. Constraint linkage maps delayed drawings to physical site blockages. Finally, evidence of closure mandates an updated 3D model. Text replies are invalid. Because of this single information blockage, the entire engineering domain is forced into a red status, failing its acceptance gate for disposition aging. When 28 first submissions result in 0 replies, the engineering flow creates a total project stall that no amount of site manpower can overcome. Returning to the physical site, we can examine the site readiness metrics. The field teams claim their enabling works and physical site preparations are actively underway. The diagnostic reality shows that out of 9 critical site readiness activities, only 1 is actually complete. That single completed activity is the concrete trial mix, demonstrating exactly how rigidly physical work must be verified to pass a quality gate. On site, field workers physically test the fresh concrete using a slump cone to accurately measure its workability before it cures. This flowchart outlines the 6-step evidentiary chain required for acceptance, starting with an approved design mix. Step 2 requires batch tickets for material traceability. Step 3 logs the fresh concrete workability tests. Finally, witnessed laboratory results must be secure before any formal acceptance is granted. A 7-day curing cube undergoes destructive lab testing in a hydraulic press to verify its structural integrity under exact loads. Photographs of a successful pour on site do not release production concrete. Only formal, traceable lab data satisfies the technical requirements of the quality gate. We now move to the most complex and expensive domain of the build, mechanical, electrical, and plumbing, or MEP, and its commissioning. The contractor claims they are currently planning the MEP works. This chart represents the project commissioning ladder. This multi-stage verification framework dictates the entire MEP lifecycle. The first step is CXL0, or design review. This establishes systemization boundaries, asset tags, and testability requirements before a single piece of equipment is procured. Looking at the MEP system readiness diagnostic, every single major MEP system is currently failing its baseline readiness check. Isolating the mechanical cooling systems, specific missing engineering data, loads, psychrometrics, and hazardous zoning is blocking progress. For electrical utility and UPS systems, a rigorous testing route maps the exact path from initial dead tests to integrated failure recovery. The final load bank proving phase requires massive industrial testing equipment to simulate peak facility electrical loads. In hyperscale data centers, systems aren't tested at the end. Testability must be built into the very first boundary drawings at week 2. This strict executive framework must also handle edge cases when critical project workflows go off script. This chart details a 5-step procurement process. Consider what happens if a major vendor attempts to ship long lead equipment without passing the factory acceptance test. This constitutes a hard stop. Accepting uncertified equipment onto the site imports massive, unquantifiable risk directly into the final commissioning phase. Physical blockages face the same scrutiny. Here, site logistics are currently constrained by an active, third-party utility cable relocation. Clearing this physical constraint requires a strict protocol: mandatory surveys, ground-penetrating radar scans, and trial pits. Executing a trial pit on site requires careful, slow hand digging to safely expose buried utility lines without damaging them. The management framework treats digital omissions like missing FAT data and physical blockages like buried cables identically. Both are hard constraints requiring verified evidence to clear. This Week 03 mandate issues 5 directives to the project teams. Directives 1 and 2 break the engineering bottleneck by forcing prioritization of critical packages and escalating zero-reply submittals. Directives 3 and 4 secure the site by closing utility permits and establish baseline governance by approving MEP zero-level gates. The ultimate endgame of executing all these rigorous controls is a fully operational, integrated, and completely flawless data center facility. The overarching philosophy is printed at the absolute bottom of the mandate: 1 data cutoff, 1 accountable decision, 1 verified closeout, 1 reliable plan. Hyperscale project control depends on the ruthless administration of objective reality. In this environment, every activity, from personnel mobilization to dirt removal, must be substantiated by a verified evidence trail.